Hello world and welcome to Hacks. In today's video we're going to be looking at buffer overflows on TryHackMe. Now, I've tried to learn buffer overflows like a dozen times and I've never gotten really far. I've always had trouble with the debuggers. I've tried using Ghidra and stuff like that and I always stumble and fall flat on my face and I've never really been able to do it. So I've been busy recently with TryHackMe, so apologies for not uploading the video. Work's also been manic, but I was on TryHackMe and I've blitzed through a number of the learning paths and I've got to the offensive security or the offensive pen testing learning path, and in there's a module on buffer overflows and I was like, oh no, not again. But I decided I will give it a go, and I spent all day yesterday trying to get it to work and it kept buggering up. I kept getting to the final bit where you had to get the reverse shell, you put your payload into the script and it just didn't work no matter what. Woke up this morning after a long break and was like, right, let's try it again. Went through the process step by step and it worked. The payload come back, and I'll tell you what, the joy I felt when it actually worked was overwhelming. Succeeding at something that you've been failing at for a long time was just amazing. And then I went on and I did the second one. So today I want to do the third one, oscp.exe on overflow 2. So what it is, it's a program called OSCP for the Offensive Security Certified Practitioner. It's practice for that, and on there's a program called oscp.exe, which if you netcat to it on port 1337, it has a section on it called overflow 2, which, well, overflow 1, overflow 2, there's like 10 sections and you can do buffer overflows on all of them, and it's a lot of fun, if not a bit frustrating at first, but if you enjoy learning and when you finally succeed, it feels great. So yeah, the IP address of the box we need to connect on is 10.10.237.191, and we're going to be looking at overflow 2. So if we just jump here into my virtual machine and we look for Remina, we should have a box already at the bottom, 237.191. I must remember to extend the time because this video will probably take longer than an hour to go through, but hey. So quick connect. Oh, need to throw on the VPN like a Wally. Let's cancel that and try again. What am I doing? There we go. So we're on Windows desktop, and the first thing you see is you've got Immunity, Debugger, and a bunch of other applications. All you need to do, right click Immunity and run as administrator. That's pretty important. And then you want to set your environment in, well, you want to set Mona up, and the way you do that is you run, I'm going to be copying and pasting a lot. You can pause and follow through. Yeah, not like that. But yeah, Mona config, set working config folder, C Mona, and what that does is it sets the working directory for Mona in C Mona. So if we set that, it should get a log window come up. Fantastic, that worked perfectly, so we can just minimize that. Now, what we need to do is we go to File, Open, and oscp.exe, and we can run the program. To explain a little bit about the windows, well, I don't really know, to be honest. That's the register window. It shows you all the memory address registers, and this is the sort of assembly window, if you know about assembly, where you move bits in and out of memory to actually run the program. But yeah, that's how programming works at the lowest level above binary and stuff. So anyway, the program is running. Now what we need to do is we head back over to the website and we head to section 1 and we grab our fuzzer script. So we grab that and head back to our VM and jump into our terminal. I'm just going to make a directory called overflow 3, move into there. What am I doing? CD overflow 3. Can't type. Fantastic. Okay, so then we're going to do vim and we're going to call it fuzz.py. And we're just going to click insert and we're going to paste that into there. Now as you can see, it's doing your import socket in Python and it's connecting to the IP address, which is currently right. It's connecting on port 1337 and it's using a prefix of overflow 1. Now we don't want this because we are attacking overflow 3, but you probably want this. overflow 3. If you're doing number 1, then you want number 1, 2, number 2, and so on and so forth. And that's all we need to do for the time being. We just write and quit that, and then we do python 3 fuzz.py, and it will send bytes to the program until it crashes the program. And we will wait for this to go through. 700 bytes, 800 bytes, 900 bytes, 1000 bytes, 11, 12, 13. And I think it's crashed. You sort of saw a little bit in the background there where it crashed at 1300 bytes. So we now know how much it takes to overflow the buffer. So it's 1300 bytes of data causes the program to crash. So what do we do now? Well, we need to use Metasploit to create a pattern. And in order to do that, again, I will be copying and pasting everything because it's just going to be quicker. But you do user share Metasploit framework tools exploit pattern. It's a Ruby script, and we know it's 1,300 bytes. But what we should do is we should increase it by 400. I read that on the actual walkthrough and from a couple of other YouTube videos. So 300 plus 400 is going to be 700, 1,700, I think. My maths is awful, but never mind. I don't really think it matters too much. And then what we need to do is we keep that there, but we head back to TryHackMe. And we grab the exploit script. Bing bang bong. Your script is now mine. Let's open a new tab. Sudo vim. I'm just going to call it exp.py. And then I'm going to go type my password in. And then we're going to go insert. We're going to paste the script. Boosh. And we can again go up here, and we need to set overflow 1 to overflow 3 because that's the one we want to attack. Make sure you've got a space after that, and then we head over to the pattern that we just made, and we're going to pop that into the payload. Whoops, a daisy. Already on insert, and then we're going to hit, and then we're going to escape, and we're going to right quit that. Right, now we need to grab the program again, so we're going to file open. You have to open the program and run it again once it's crashed. So anytime you do a step, whether you're working out the bad characters, working out this step, if you've previously crashed the program, you need to reopen it and rerun it, otherwise it just won't work, obviously. So then we have our exploit script, and we can do python 3 exp.py, boosh, and it's sending the evil buffer to the program. So what we do next is we go back to the program and we have a look, and you can see there that the EIP register has our value in the string right there. So that's crashed it good. Right, now we need to use Mona, and again, I'm not amazing at this, I'm following my own notes that I've read, but we know how much string data that we have there. So we sent it 1,700, I think it was it 700? Yeah, 1,700, and we can now get Mona to find the distance, or find MSP distance. Again, I'm not too sure what all this does, but that's something I will work out later. And we need to set the distance to 1,700, and what we're looking for in here is the EIP register, and that will tell us the sort of offset that we need to use. So providing I've done this right and I haven't messed it up, EIP contains normal pattern offset 1274. So if we go back to TryHackMe, one of the questions for all of these is how big is the EIP register? So was it 1274? 1274? Yeah, brilliant. So that worked. So can I extend the time yet? Because I don't want to run out. Yeah, so we're just going to add an hour to the box so that we don't run out of time. Okay, so now that we have the EIP register, what we can do is we can go back to our Python script, and we can exploit.py set the, is it the offset we need to set? It is the offset, and I've already forgotten the number again. Sudo vim exp.py. Don't know why I'm using sudo for. Right, so we need to set the offset to the number that Mona just showed us, which was 1274. So 1274, fantastic. Now we can set the return address, I think it is, to BBBB. Now I sort of understand why you do this, is so we can see that the EIP is being overwritten by like 424244, so you're overwriting the EIP register, something along those lines. Again, this is stuff I need to study more, but there's so much to buffer overflows and the way assembly works that it's quite a lot to sort of process in one day. Okay, now I think we need to empty the payload as well. So what I'm going to do is I'm just going to click insert, and I'm going to hit return, I'm going to hit escape, then I'm going to do DD to get rid of that, and I'm going to hit enter again. I'm just going to come back and add that quotation mark back in, right, quit it, and now I'm going to reopen the program, because again you need to do that. I'm going to rerun the program. We should be able to run our Python script again, python3 exp.py, and what this should do is this should crash the program, and it should show that the EIP, or, sorry, the ESP, no, the EIP, yep, sorry, right there, is being overwritten by 42, 42, 42, 42, so it's sort of proving that our theory is sound. Return and replace EIP should be, yep, cool. Right, now we need to generate a byte array to go through and identify all the bad characters, because if you've got bad characters in your shell code, your reverse shell, when you finally get to exploit it, is not going to work. It'll hit the bad characters and it will terminate the program, and such bad characters are things like null bytes, as you've probably seen in some of my other videos, or if you're into cybersecurity and hacking, you probably know what a null byte is, but it's effectively a terminator or a null byte. It ends programs. It can be used to sort of escape parameters if you're trying to look for remote code execution on web applications. It's just like end, you know, it's a null byte. So yes, that should work. So you can see there we're creating a byte array, and we're excluding that byte of null byte. And we should get the log window come up, and it will say, yep, there's our byte window. Now we need to create one that we can use for our payload. So we go back to TryHackMe, we go to the first page, and we find this naughty little script which just creates a byte array for us. So all we're going to do is we're going to jump back into Vim. Don't know why I'm using sudo again, but hey, and I'm going to call it bad.py because it's a naughty boy. And I'm going to insert, and I'm just going to paste that there. You can see I'm not making any changes at all. And then we're just going to do sudo. I suppose I will have to do sudo now. Python3 bad.py. Boosh. And then you can see we have our byte array excluding the null byte. So we're going to take that, and we're going to go sudo vim exp.py because that's the payload we want. And we're going to come over here, and we're going to input it in there, and we're going to paste the byte array. So you can see that it's missing the null byte, but every other character is in there so far. And what this will allow us to do is when we send this back to the application, we can then compare it with the byte array that we've generated using Mona, and it will look through the stack and be like, okay, we found this bad character, this bad character, this bad character, and through a process of elimination we can go through removing the bad characters from the byte array, and that will allow us to sort of sanitize our payload and make sure that it's going to work when we set up our reverse shell. So let's escape, let's right click that, let's go back over to here, let's file, open the program again, run the program again, and provided I haven't missed a step, we can just do Python3 exp.py, boosh, and that should crash the program again. You can see the EIP is crashed. Now what we need to do is we need to compare what we sent it with the byte array, because the byte array has the null byte missing, so we can compare it to ensure that it's going to work. Okay, right, so this is where we need the ESP address. So yeah, you need to grab the ESP address because that's where the sort of exploit is going to be running. We're going to right click that, and we're going to click on copy selected to clipboard, and then I'm just going to come down into my notepad quickly. I'll show you it in a second. I've just got a bunch of notes on here that I've been taking for this whole thing, but there you go. I just sort of, this is my work process. It's a bit crap, but I'm just getting the addresses, pasting it onto my commands, and copying it in. And what this will do is this will compare what we sent it with the byte array to see whatever bad characters there are. Fantastic. So you can now see there, the first bad character, as always, is going to be 0, 0, but the next bad character is 11. So what do we need to do with that? Well, we need to go and tell Mona to create a new byte array, which has 11 in it as well. So let's bring up Notepad again. And yeah, I realise how bad this is, unorganized, but still. Right, we don't need speech marks, so we need to tell it to create a byte array with x11 missing, because that is a naughty character. And then we're going to go back into Mona, into Immunity Debugger, and we're going to paste that, and we're going to say, okay, create a new byte array with those characters missing. Fantastic. Okay, but now we need to do that to our exploit, right? So we're just going to grab the byte array that we created using the bad script. We're going to head back into Notepad. We're just going to paste that over there, and we're going to Control F, and then we're going to do x11, and you can see there it should find it right there, and all we're going to do is delete that sucker. So we're going to grab the script again, and we're going to head back into our exploit.py. Go into there, and okay, right. God damn it. Sudo vim exploit.py, cool. And we're just going to do the same again. So we're going to insert here. We're going to insert a line break, escape, DD to delete that, come back up. It just saves actually having to delete it all. And then we're going to paste our byte array in there, and we're going to right quit. And then we're going to do, don't forget, we got to reopen the program and run it again. And we're going to do sudo python3 exp.py. Yep, cool. And that's sent the evil buffer. Then we come back over here, we grab the ESP address again, because it could change. Don't always assume that it's going to be the same. And then we're going to come back to our notepad notes. We're just going to copy, we're just going to append that to there, and we're going to compare it to the new byte array. So we sent it new data, we created a new byte array, and we're going to see what special characters. So yes, 0, 0, 11. Now we need to look at 40. I'm not sure what it was before, but if you remember the names like 11, 11, 40, what can happen is the bad character that precedes the next character could be flagging the next character as a bad character. So we need to go through it one by one and make sure, because if I check 40 now, it could be that 41 isn't a bad character. So we'll have a look at that, we'll run that now, and we'll check. So yeah, first thing we need to do is we need to go back into here, and we need to create a new byte array. Yep, so what was it? X40, wasn't it? Let's double check. Blah, 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 blah. Yep, so 40 is the next bad character. So head back to Notepad, and we need to tell Mona to create a new byte array with null byte 11 and 40, because those are our bad characters so far. I probably am over explaining it. Paste. So that's created that new byte array, and then as we did previously, we head back in here and we look for X40. And you can see it's right there, so we're just going to take him out of the equation, nuke that bad boy, grab our payload again, head back into our terminal, and sudo vim exp.py, come back down into here. I could cut this out, but I'm not, because this process took me forever to get right, and I kept messing it up halfway through. So we're going to do that, we're going to exploit, we're going to DD, we're going to insert again, come back up here, speech marks, over, and paste. Sweet. So that has the 3 bad characters removed now. So what we need to do is we need to file, reopen the program, rerun the program, and re-exploit the program. And now let's have a look at the ESP address. Let's grab that, head back to Notepad, let's throw it back onto the end of the compare, let's throw the compare back into immunity, and let's see what's happening now. So remember when I said that 41 might not be a bad character. Well, 41 wasn't a naughty character, it was his brother 40 that was taking the piss and making him look bad. So our next one is 5F. So again, we come back down to our notepad, and we can see here we have to add X5F, and then we can, is it X5F? Let's just double check. X5F, fantastic. So we come back down to notepad and we search for X5F, and then it's found that next occurrence, and again it's a long-winded process of elimination, but we have to create the byte map. Yeah. Sweet, and then we have to modify our payload with our new byte map that eliminates that character. Vim Python. Oh, what am I doing? P.py. Yeah, it does get a bit once you've been doing it for so long. Like I said, I spent all day on it yesterday, and you sort of lose track of where you are. So I need to escape DD, which is why I kept running into so many issues. It was like, okay, I've already removed this character. Does the byte array include this character? And then, yeah, you know, it's as much attention to detail as you can pay. If you've crammed it all in, and yeah, you can easily sort of mess it up. Right, so let's get that back up there. Let's right quit that. Let's go back to our program and open it and rerun it, and then we can relaunch our exploits. Sudo python 3 exp.py, sending evil buffer, and again we head over to our program. We grab our ESP, copy, select into clipboard. We head back down to here and we paste it onto the compare command. You can see there the actual address has changed. And we'll just compare it back to the byte array and see what it is now. So we have, which one was that? 5F, so B8 is the next one. Whew, okay, I have a feeling this might take a while. Okay, so we need to regenerate our compare with B8. So we need to regenerate our byte array, XB8. Yep, because XB8 could be making B9 look bad, because 789 or something, I don't know. Right, so yeah, let's create the byte array. Yeah. Let's hit that. Cool, that worked. Now let's go back to our notepad and find B8. I've already removed B8. Did I just do B8? I'm not sure. Find next. XB8. Nope. Cool. I thought I'd done it then. So this is it. Once you've done it and you're staring at the screen for so long, you sort of forget. Oh, did I do that one? Okay. Right. Let's speed it back up again. So we need to go back into our script. Sudo vim exp.py. Let's come down to the payload. Highway to the payload. Escape DD, cool, clear that. Insert speech marks, boosh, bash, right quit. And then we need to reopen the program again. I mean, okay, it is repetitive, right? But when it works after you've struggled with it so long, it's so good. Right, let's run that again. That should crash the program. Grab the ESP, copy selected clipboard, head back to notepad, grab our compare. Throw the address register in there, looks the same that time, and let's paste that and let's have a look. So we have B8, and you can see now B9 is gone. B9 was actually a cool guy. It was B8 that was making him look bad. I suspect it's going to be the same with EE and EF. EE, being the dickhead that it is making EF look bad. Sorry for language. Okay, right, so we're going to go over here and we're going to grab our notes again, and we need to increase the byte array, so it was X, and I think we're coming towards the end here. /XEE, was it EE? Definitely EE, wasn't it? Yep. Oh, so let's create the new byte array with EE. Okay, so we recreate our byte array with the added EE because he's a naughty boy, and we've amended our script. Sorry, a bit of a technical issue, but it seems to be fine now. So we've removed EE from the string already. Everything is the same, overflow 3, offset, cool. Right quit that, we're just gonna run and reopen the program again, and we're gonna run that. Then we're gonna do sudo python 3 exp.py. Hopefully that works. Then we're gonna come back up here, we're gonna grab the ESP address, copy that to clipboard, jump back into our notepad quickly, as you can see there, and we're going to compare this final one and make sure that we get this window here, which is a glorious window to see. Let me just increase the font. As you can see there, unmodified, status, location, all good. So this means that we've identified all the bad characters, so that when we generate our payload, we can eliminate those characters from the payload, which means the payload will work, because if it has bad characters in it, it will terminate prematurely and it will crash and it just won't work and all bad stuff will happen and the server will explode. It won't, but yeah. So now what we need to do is we need to find a jump point in the program for us to sort of stash our payload in to execute. I think that's how it works. Again, I'm sort of guessing based on the logic deductions. So we're going to use the Mona again, and we're going to use Mona jump to find a jump point in the program that will hopefully allow us to yeah, do some fun stuff. Okay, so it's crashing, right. So why is this crashing? Because it wasn't crashing before. Let me jump back over to the internet quickly. Might be to do with the quotations I'm using or something, but let's find out. Yeah, I think it's to do with the quotations I'm using. For some reason it doesn't like it. But yeah, I was having this issue a moment ago and I thought the program just wasn't gonna work. Right, let's try it like this. Okay, so we can see there, we have to take that off there. That off there. Now let's try running this. There we go. It's very weird that it's done that, but what you should be able to see now is we have two memory address registers that eliminate all those characters that we can use for a jump point. So I'm just going to copy the address to the clipboard. And I'm just going to paste it into my notes quickly with the sort of jump address. Okay, so what do we need to do now? So we know the jump point. What we need to do now is we need to generate a payload, I suppose. So we're going to use this string down here, MSF Venom, Windows shell, reverse TCP. Just going to check what other people have done because I was having issues with this earlier. Windows shell, reverse TCP, 4444, BFC. Yeah, that all looks good. Okay, so we're going to grab this. We're going to head back into our terminal. We're going to open a new tab and we're going to do sudo msf venom and generate our payload. MSF Venom is sort of part of Metasploit. I believe it used to be a standalone or the other way around, and it allows you to generate payloads. So you can do fun stuff with APKs, you can obfuscate stuff, you can encode stuff. It's really good. So if you're ever trying to get stuff running on the box and it's not working, then you can use MSF Venom. So now I had all these errors before. And I thought something was going wrong, but we're just going to continue. If the payload doesn't work, then hell, whatever. You can, yeah, work it out. But you can see here, we don't want the semicolons. We're just going to copy everything up to the quotation marks. And we're going to sudo vim, let's do it in another tab actually. Sudo vim exp.py. And this is going to be our payload. So we come down here and we do our old Vim trick, and we hit return, escape dd, come back up, hit insert, put the quotation marks in, which we'll probably have to delete in a second. Yep, and then we want to encode it well, we want to enclose it in brackets. Now I can't remember whether they come before or after. Let's have a look. So they come after the quotation marks. Cool. So in insert, we're going to open bracket there. We're going to delete that speech mark and we're going to put an open bracket there. So that's our shell payload. That's our reverse script. But what we also need to do is we need to add some padding to it, and we're going to do x90 times 16. And this just makes sure that your exploit has enough room to run in. So we're still doing overflow 3, but we need to now change the return address to the jump point, if I'm not mistaken. Let's just double check. Right, exploit script to the return address. So we have the return address here, the jump address. Right. Yes, so what we need to do is we come up to the return address, we get rid of BBBBB. I'm just going to put a comment here and I'm going to paste that in, because what we need to do is we need to put it in backwards due to the little endians and stuff. Again, it's to do with the way architecture and stuff works, but we're going to do x / and then we're going to do 03. Then we're going to do, oh no, we're going to do /x, should I say, /x03, /x12, /x50, /x62. So, as you can see, we're putting them in the reverse order. So 03 comes first, then 12, then 50, then 62, and we're just putting /x in front of all of them. And I think that is it. I think that's everything we need to do. So if I just escape and right quit, fingers crossed, and then we want to create our netcat listener. So we do sudo nc -nblp 4444. Give it our password. Yep, did typo that. Now, at the moment of truth, we're going to come back over here. We're going to reopen the program. We're going to rerun the program. We're going to panic because we got a strong feeling this isn't going to work. So we have our payload. We're going to close down a few of these windows just to tidy it up a little bit. And unfortunately, I have a feeling this is going to be so anticlimactic. But let's split these windows. One over here, one over here, or maybe the other way around. Yes, I'm intentionally wasting time. Okay, right, here we go. So we're just going to do sudo python 3 exp.py. Oh my word, didn't expect that to work, but as you can see, we have py. Using this shellcode that we generated by eliminating all the bad characters, we've created a reverse shell through that program that has created a buffer overflow. Oh, it's so good. Yeah. Oh, can you tell how happy I am? I'm glad it worked. I'm glad it worked. You can see there our user. You can do everything in there. Sysinfo maybe. Sysinfo isn't a command. Yeah. Anyway. Oh God, that's such a relief. So that is how you do buffer overflows in TryHackMe. This OSCP prep here. Like I say, I've always struggled with it. I've hated it for the longest time. And just then, I was getting a bunch of errors, and I was worried it wasn't going to work. And I started thinking, okay, we can just switch to number 2. But then I looked at a Medium article. Medium's great for tech write-ups, by the way. I write on there a lot. And some guy did it successfully, so I assumed there was something wrong with my syntax. And it turns out it was just my quotation marks. A lot of the times, what you'll find is you've just fudged a character somewhere. Yeah, but that's it. Such a cool thing. Yeah. Hard to get your head around. There's still so much I need to learn about it, like the EIP and ESP, what they all do. I know it's all part of assembly, but I wanted to create a video on this just because of how cool it is. This is what I've been busy with, honestly, with TryHackMe recently. I've probably sank way too much time into it, sort of burying my head in the sand at the moment with everything going on in the world. And I was just like, okay, well, I will see where I can get to. And yeah, within a few weeks, I've got into the top 1%, not to brag or anything, but yeah, TryHackMe, it's absolutely awesome. If you've started on Hack the Box and find it a bit difficult because you're new to cyber, then come over to TryHackMe, sign up, get an £8 a month subscription, and look at all these learning paths you can do. Introduction to Cyber, Junior Penetration Tester, Pre-Security Defense, Offensive, yeah, and you get certificates for each one of them. And yeah, if you're looking for a way to get certificates but maybe don't have the financial means to do so, you want to take your OSCP or your Pentest Plus but you don't have the money to do it, but you can afford like £8 a month, bit of a contradiction I suppose, then absolutely jump on here, get the certificates, put them on your LinkedIn. It shows a potential employer that although you haven't taken these like formally recognised certifications, that you are willing to invest the time into doing it. And again, I'm not affiliated with TryHackMe in any way. I've known about it for a while but never really got into it, and then the last couple of weeks I just sunk my teeth into it for fun, just to see what it was like. And so far it's been amazing. It really walks you through everything that you need to know. So from things like Kerber roasting to privilege escalation on Linux. Again, I was a bit rusty on PrivEsc on Linux. There were some bits I didn't know, and from what I've got from the resources in these learning paths, there's loads. But there's also a lot more as well. You've got all these different paths you can take, Nmap, Burp Suite, but then you've got full-fledged networks that you can attack, Throwback, and you can see there you've got your pivoting points, and you've got Halo and Hollow and Reef, and yeah, you can go to your public profile, you can share it with people, you can download your certificates, but you also get badges to make yourself look cool, and it shows you all the badges that you've unlocked. So yeah, if you're new to cyber and you're looking for a way to learn some stuff, get on TryHackMe. It's awesome. Again, not a promotion, not affiliated, but I just think it's fantastic. But anyway, that's it for me today. Do some buffer overflows. It's friggin' cool. If not a little hard to learn at first. But yeah, kind regards. Bye.